Everyone on this webinar today will get a copy of the slides, and if you have a question during the webinar, you can type it into the dialog box on the screen in the bottom right, and we'll try our best to get to them at the end of the presentation. So this is the agenda for today's webinar. First, our meteorologist, Leo, will talk about weather past and future. Then we'll see how that weather manifests itself into our hydroelectric forecasts for WEC. And then finally, how these inputs translate into power prices that come out of our Western production cost model. And at the very end, we'll do a brief summary for you. So at this point, I'm going to turn it over to Leo.
All right. Hi. Good afternoon, everyone. So before looking at the upcoming spring and end of the winter, we want to review what happened last winter. So I have a map here of the snow water equivalent of dated January 12, 2014 in the bigger format, and in the smaller format we have the actual situation as of early this week. So if we compare really quickly, there's a little bit less snow in the Cascades this year than there was last year. However, in the Sierra in California, given the wetter December, there's a little bit more in the Sierra in California. Also, if we compare the Upper Columbia last year to today's situation, there is more snow last year than there is this year. In the Snake, in Idaho, and the Flathead River, then there's a little bit more snow over there. So if we want to look at last year's upper level pattern, there was over the December to February, there was a pretty consistent pattern when we averaged it out the whole 3 months of the winter. That was characterized by big high pressure over the Eastern Pacific, and then the polar vortex over the Midwest, and WEC was stuck between both patterns. And this has impacts at the surface. When we have such a flow, most of the storms will travel from northwest Canada into the Rockies instead of coming off from the Pacific. So it explains a lot of the droughts that we aggravated in California last year. So going to the next slide, looking at temperatures, over the whole winter, California had a very, very mild winter last year. And in the Pacific Northwest states, it was a mixed situation. Whereas the Snake was warmer than normal, further north over the winter, there were several Arctic outbreaks that pulled down the average and made it colder over the 3 months. What happened also is that the lack of storms, every time there was a cold, high pressure, the air would stay trapped for several days and even several weeks at times. So it generated those colder anomalies in the north. Looking at precipitation on the next slide, this is the biggest impact of such a pattern last year. Basically, California was bone dry most of the winter, and most of the precipitation anomalies above normal were restricted to Montana, Wyoming, so a little bit in the Rockies there, and further to the west, there was also a deficit in terms of precipitation that was directly related to this kind of storm track that we experienced last year. The next slide, consequently, looking at the wind speed, wind generation. In general, the winter is not the biggest season for wind farms in BPA, which are located in the Columbia Gorge between Oregon and Washington. But looking at last year compared to normal, the wind generation was less than usual, and that was directly linked to the lack of winter storms, which are the main factor of driving storms. However, you look at east, there was more wind than usual in the eastern states, but wouldn't have as much of an impact on BPA. So now we're ready to move into the actual outlook for the winter. This outlook was prepared before the start of winter, so before December, early December. And our expectation at the time was above normal across most of WEC, less intensity on the coast, most of the strongest above normal in the Snake and the Great Basin. In terms of precipitation, contrasting with last year, we had expectations of much above normal over California, so it's a big contrast there, in Oregon. In the northern part, going into Colombia, then more of a seasonal pattern. So we want to verify how so far in the winter it verifies. So the next slide is a slide with the actual observed weather for December, and then the 12th first day of January to the right. And December was not unexpected to be warm across the country. So it was warm across the country, including the West. The main point here is that most of the precipitation we've had in the West was concentrated over Northern California in December, and that's a huge difference compared to last year over there. But since the last week of December in California, there hasn't been much precipitation, as we can see at the bottom right. Northern California, the Sierra, has been really dry for the past 2 weeks or so, and most of the precipitation is limited to the north. And even though this weekend we're expecting a little bit more precipitation going in the Pacific Northwest, it's not expected to really change like throughout the balance of the month. So knowing that, what are the expectations for finishing the winter in February? Our expectation is we're still going to finish on the milder side for WEC, contrary to the rest of the country, which will probably turn colder, but it's not the main point. The main point here is that we expect some return of above normal precipitation in California and the Sierra. However, in the Pacific Northwest, we expect drier than normal weather, which is a little bit more of a weak El Nino, at least signature there, that was taken into account in the forecast. I would say there's more confidence that the below normal signal in the Pacific Northwest will verify, whereas the California wet signal, it might be of a lesser degree. So this is my point for February forecast. Now moving into the actual ENSO state, so El Nino Southern Oscillation state. So now this slide is a little bit busy. There's a lot of stuff here. So at the top of the slides, it's the actual zones on which we really focus our attention in terms of sea surface temperature anomalies. So, and at the bottom left, there's a graph of the past 4 years. So the last El Nino episode was in 2009-2010, which is not shown on the graph, and then it was followed by La Nina. Basically, La Nina and El Nino are characterized by anomalies that are bigger than 0.5 degrees over 3 consecutive 3-month periods. And we have to say that since 2012, there hasn't been a El Nino or La Nina present. It's been in a neutral stage. In the last 6 months or so, there's been more of a trend towards the El Nino, but we're not there yet. And the very short-term signal in the past week and the past month or so are sort of diminishing the anomalies of sea surface temperature. We can see it in the graph with the change in weekly SST anomalies in the bottom right central sort of. It's been cooling down in the central Pacific a little bit, so we're still in neutral stage there. There's a reason to that. In the next in this slide here, we have the explanation behind the temperature variation that are found in the different zones of the central Pacific. It's something called Kelvin waves, and basically, not going into depth and details, it's a oscillation in which the temperature anomalies are spreading from the western side of the basin towards the east, and it's adding some variability in the sea surface temperature anomalies throughout the past month. So we see that in spring it was trending towards a El Nino much faster, and then in the summer there was a break, there was a pause, and the pause is really shown by that colder phase that we see centered over the summer in the central Pacific, and then it warmed up over the fall, and lately it's been cooling a little bit. So it might explain why the sea surface temperature have been dropping a little bit, but you know, we might go on under a warmer phase soon. So probably in the end of the winter into the spring, we might be just above the threshold for qualifying the ENSO state as a weak El Nino. So when we look at the table of the past few years, and the past 2 years, I would say, we've been in a long, long stretch of neutral anomalies within 0.5 Celsius degree. And it's been neutral throughout the summer, and then in the fall, it's been reaching the threshold of El Nino. But as I said previously, we need above 0.5 degrees above normal sea surface temperature to actually call that an El Nino. So it's something that's going to be confirmed in the next 3-month period that we're currently in. We're nearly there, but we're not completely sure, just given the sea surface temperature that have been trending a little bit cooler recently. It might take a little bit more time, or we might even fail at actually verifying a full-fledged El Nino. And in any case, I am not expecting something strong out of this. So looking at that slide, it's showing the actual sea surface anomalies, how they are spatially distributed. They're mostly over the central Pacific, and in the eastern Pacific it's been not as warm, so it will be a weak event in any case. And the consequence of that is that it's not going to be the only factor playing out over the west weather. It's not the North American weather. It's going to be a factor among the others, but it's so weak that it's not something that we can take and make inferences simply based on that. On the next slide, we're changing a little bit of topic, but it's still very important. As you all know, California has been in severe, extreme, exceptional drought. And there were some hope that in December and going into the winter, because of that El Nino thinking, that California would at least reduce the drought intensity. Well, actually, it had a little bit with the part of December that had some rain. And late November to mid-December, I would say, there was several storms that eated out the deficit of precipitation. But then it didn't last. And since then, it's been pretty dry. And what has been happening is that the drought monitor has pulled down all the northern part of California from D4, which is exceptional drought, to D3, which is extreme drought. So it's a slight improvement, but nothing that is indicating that we will erase that drought anytime soon. I'm not expecting that the drought signal is going to go away throughout the summer, if not into the next winter. So it's going to be part of the picture up to there. And with our spring assumptions as well, I put two maps with the spring assumption from the CFS model, just as an early indication. But I'm not really deviating from that. I think it's a pretty reasonable outlook there. So the theme is still mild and dry over the northern part. There's a little bit of a rain signal, like above normal precipitation over California, but it's in comparison of normal. And the normal, typically the precipitation amount from March to May are decreasing pretty sharply month over month, because the main months of the rainier period in California are really from the fall into the early spring, and it's still mild. So this will go straight in reservoirs, but I don't think it's going to accumulate with snow, because the snowpack right now in California is turning under seasonal, like about 40–50%. So, and I'm not thinking any of those patterns are favorable for adding more snow in the Sierra, and then the Pacific Northwest is going to stay dry. So that's what we're thinking right now. And I'm passing it to Chris Jilka, who is going to talk about hydroelectric forecast.
Great. Thanks a lot, Leo. That was great. So the agenda for the second half, we're going to talk about the current state of the snowpack, some predictions. We'll go through our California and Pacific Northwest hydro forecasts. We'll talk a little bit about regulatory implications, a brief summary of the major generation and transmission outages, and then we'll just summarize the latter half of the webinar. So let's start by zooming in on Leo's earlier snow water equivalent slide. This is Tuesday's data compared to the same exact date of last year, so January 13th, 15 versus January 13th of 2014. To the left is 2014, the right is 15, and right away you can see that there's less snowpack in BC. If you look at the second square down, that is the Cascades that Leah was talking about. There's also a lot less hydro or snow water equivalent there. The Cascades does supply a minimal amount of flow to the main Columbia River stem, and it doesn't really impact hydro production all that much. And it's difficult to see, but the lowest square on the slide is the Snake Headwaters, which the color is a deeper red instead of a magenta, and that's indicating deeper snow with a higher snow water equivalent, some of the highest values of this area. So what you're looking at here is a screenshot of our actual WEC term product. It's in our renewable section under hydro and then snow. It's basically a tabular version of the map that we had on the prior slide, and it's sortable by column header. So what I did is I first sorted it by the relevant river basin size, and then what I wanted to do is take a look at the current snow water equivalent relative to what the average is for the same time of the year. And then that data is easily downloadable into Excel. So from the Excel data, this is what the graph data looks like using a two-axis graph. The horizontal green line in the middle is 100% of normal, which you can see is the left axis. The right axis is the snow water equivalent as a percent of normal. And then if you look at the graph and move from left to right, you can see by the black bars the four largest runoff basins are roughly, I'd call it 80 to 100% of normal. But if you look at the graph or the whole plot in its entirety, the system in aggregate, really the majority of the basins are 40 to 80% of normal. And then if you look to the far right, the basin with the highest values is the Snake Headwaters, which in terms of runoff area is one of the smallest. So here's our forecast for the Pacific Northwest. I apologize for the busy chart. I wanted to put a lot on here. We use the BPA hydrogeneration as a proxy for the whole system since it's such a large part of the whole. And this graph shows the last 5 years versus our forecast. And then if you're looking again from left to right, the red dotted line is year-to-date actual BPA generation starting January 1st. And you can see as you move to the right, the large water years are indicated in green and red, and that's 2011, 2012. And then in contrast to that, the lowest plot on the graph is 2010, which is indicative of a pretty poor early spring in terms of hydro production. Well, our forecast is very undramatically right in the middle. I would say it's most similar to 2013, but perhaps a little higher in the early spring. And a lot of traders and planners always look in comparison to the prior year. So in contrast to last year, we don't expect the quantities of runoff that we saw last year in March and April. So shifting gears now and looking south to California, Leo was summarizing the change in snowpack in one of his earlier slides, and it is healthier than this year. But to really get an indication of how healthy hydro production is, you got to look at the reservoir numbers. They tell the real story. That's basically storing the amount of energy available for a later date. Southern California or even Northern California is a summer peaking system, so that's when they need the capacity the most. And they also need ancillary services in the spring. So the reservoirs depicted by the green squares are the most critical. These three locations hold the most storage and have the largest single dams below them. They're dams like Shasta and Edward C. Hyatt, which are 3 to 600 megawatts. And the rains of December were very useful, but the typical rainy season in California is October through March. And there's really not enough time in this season to get back to normal in the short run. Will most likely take years. So years for the blue bars to reach the average value there. And like our BPA graph earlier, we forecast the hydro generation in the CAISO as a proxy for the whole state. It's probably 90% of all the state. In this case, we look back 3 years, and that's only due to lack of data on the California ISO's part. So going from left to right, once again, you see the red plot that represents actual generation. Now, in this case, I went back a little bit further. I started from November 2014. So you can see the bump in generation due to the rains we saw in December, where it peaked probably around 1.7 gigs. And we will not expect a pickup in generation really until we get into mid-March. And also, we don't expect that the values that we saw in late spring of last year, as the expected earlier and warmer, wetter weather that Leo spoke about earlier, will ultimately lessen the June flow. And then gradually, as spring turns into summer, hydro does become more critical, and it's also projecting out pretty far, put downward risks on our base case from really June out. So going back to the Pacific Northwest, it's important to know that natural stream flow up there is impacted by regulatory policy. And two of the biggest drivers are flood control and the FCRPS BIOP, biological opinion. And that establishes a set of actions for dams to protect endangered species like salmon. And by actions, I mean minimum flow levels, spill patterns and amounts, different timing, total dissolved gas, and that's gases like nitrogen in the water that's caused by spill, and it can be harmful to fish at large levels, and it's regulated. They basically cap the spill, and it puts a cap on the amount that the dams can spill. Regarding flood control, I inserted a graphic here from the Army Corps of Engineers. Basically, the primary importance, flood control is put in place largely not to flood Portland, Oregon. And the Corps uses the latest official water supply forecast to project the minimum elevation targets for the following dams. And I highlighted in green Grand Coulee, which they call the spigot. That's the largest dam in the system. And basically, they want to lower the level behind the dam to accommodate the expected water that will run in when the snow melts. And the forecast will evolve and change through the season. And the website is updated on the dates in that little gray box sort of to the left. And as the hydro year progresses, generally the forecast becomes more and more accurate. But the takeaway from that is these elevations are short-term targets, and the entire system is coordinated to reach these minimum levels at the specified time. That's a mandate. And getting back to biological opinion, 2013 and 14 saw record-breaking numbers of salmon, which is great, returning from the Columbia River, or returning to the Columbia River. But even with the success of returning fish, we expect the actions of the dams around fish passage to reflect that they are still considered an endangered species. And in summary, we don't expect the short-term success in these fish counts we've seen to change really the management of the systems too much in the next hydro year. This is a very brief summary looking at WEC as a whole of large units and transmission segment outages. If we skip down to the first major transmission line outage, the DC tide, it comes out on February 9th. Our dispatch model around this time period it is calculating mid-sea off-peak dipping into the mid-teens, and I would say there's a downside risk on that depending on the thickness of the coal supply stack and the short-term change in the hydro forecast. We don't expect the ACD rate to do much since the projected dispatch flow in our model is lower than the megawatt limit level there. And then finally, the two California outages there, which are ongoing, they don't pose a risk to hub pricing, but we do say there might be a risk on nodal LMPs around those transmission segments. And finally, we'll move into pricing impacts. So we incorporated all the meteorological forecasts within our production cost model, and we basically get these forward curves. And in this case, we're looking at on and off peak power prices for the two most liquid power hubs in WEC, which are Mid-C and SP. And in general, our prices are slightly higher than the market. If you look at the mid-C curve, you'll see that the largest delta is in April mid-C for on and off peak. It's hard to know exactly what the market is thinking, the collective market, but it makes some sense to me that we do have less projected hydro flow in April than occurred last year, so that could explain some of that variation. And then I'll end with the forecaster caveat that statistically we're at a stage where a little over half of the snow of the year has fallen in most places in the western mountains, so there's still significant time for deviations from what we've observed and even what's baked into our base case. So in summary, the ENSO state is now borderline or neutral, potentially a weak El Nino in the spring. We're still waiting for that third month of confirmation for the ENSO. Pacific Northwest weather will be milder and drier than last year, and you have corresponding lower loads. Warmer and wetter than expected, or warmer and wetter than the extremely dry last year in California. Less snow than normal, and then the impact should be minimal on drought as we go through the summer. And then for our price forecast for both California and Pacific Northwest, we expect less hydro generation for most of the spring relative to last year, and our forecast is generally higher than the market. So that wraps up our presentation. Liu and I thank you for your time. We're going to take a small break right now to review any questions that you may have. Thank you.
All right, so we have a question here, a question about the California hydro forecast. So the question is saying, could you explain again why your 2015 CAISO hydro forecast is so much lower than last year for most of April through July? Basically, it's because we are not expecting that much more snow and throughout the winter, just because we have mild assumptions so far. So the snow water equivalent is trailing under, and it's also warmer throughout the spring, so it's going to melt, and what is there is going to melt, and the precipitation is going to flow right away. So we're going to have like hydro generation throughout, but not expecting a sharp melt right there. So that's part of that. And the reservoirs are also very, very low, so we're not expecting that it's going to get drawn really, really quickly. So that would be my answer to that.
Great. We have another question coming in here. If the November, December, January composite confirms a weak El Nino, how does that change your current forecast? And then what could it do to the Pacific Northwest snowpack?
In the Pacific Northwest, it would probably make it worse, because typically when we have more of an El Nino signature, it brings drier trends and warmer warmer than normal in the Pacific Northwest. However, in California, it would increase confidence into a wetter spring, which would probably reduce the lack of the hydro generation that we have in the current forecast by having a little bit more snow, more rain as well. So, or expectation for more of an El Nino signature would be worse, like less generation in the Pacific Northwest and more in California.
Great. Here's one more. Leo, do you have an opinion on May or June weather in the Pacific Northwest, sort of beyond what we talked about?
For June, not a clear-cut opinion yet. There's still a little bit of time ahead. I haven't made my opinion really strict there, but I think in the spring we're still looking at a very warm pattern that will not. I'm not expecting that it would break down really in the spring, and the dry trend would be mostly focused in the Pacific Northwest. It's more on California side that I'm not as certain. I think it could possibly step back up to a wetter pattern if the El Nino happens. But in May for the Pacific Northwest, I think it's going to be milder than normal, drier than normal. That's my assumption. I think it would just accelerate the snow melt, basically.
Great.
And less snow.
See, we have another one here. Does the drought affect areas in WEC beyond California? I could take a stab at that one. In effect, yes, it does. For example, in Nevada, I think there's been a drought there for over a decade, maybe even 14 years, 15 years. And Lake Mead is less than half full. And those lower water levels hurt the large dam's efficiency, like the Hoover Dam, and it's operating now at a fraction of its original capacity because of the lower hydraulic head. So you get less power production out of there. Then I'm sure there's also an effect on water for agriculture and drinking as well. We have another question. Do long-term meteorological forecasts affect your longer-term wind forecast model? Not really. For wind, we go out 7 days for the forecast, and beyond that we use a climatological forecast for basically an average capacity, value of capacity for each individual wind farm. We have another question. Somebody's asking if we can run sensitivities on different hydro curves other than our base case. And the answer is yes, we can quite easily. And an example of that would be that during the peak of the freshet or the runoff period, we often run the model 2 or 3 times in the morning in adding incremental hydro or wind to analyze the risks of light load mid-sea going to zero, basically where wind or water will take the last coal unit off of dispatch. So during the peak freshet, we run the model quite often with different sensitivities.
So we have a question about in percent of generation, how does CAISO Hydro compare this year to normal? We have pretty limited data from CAISO, but what we can say is that this year it's at least 40 or 50% below normal, and if not more. So that's that would be a part of the answer for that question.
Well, that's about it for the time we have today. I mean, I know we didn't get to everybody's questions, but we will, Leo and I will go through them one by one and then get back to you individually or any remaining questions you have, and you will get a copy of the webinar after this, so please just send us any more questions you have and we'd be happy to answer them. So once again, thanks for your time and have a great day.